Good afternoon, ma'am.
So let's continue our lecture. We were discussing about the convolution theorem in Z transforms. So we have one more example, then we'll move to the next module, that is difference equation. So we'll just go through the basics of difference equation, then we directly start the application of Z transform, that is the solution of difference equation using Z transforms. So let's start. Now see, nothing is mentioned here. Using the convolution theorem, prove that this 1 by n factorial star with 1 by n factorial is equals to 2 power n factorial. Now, even if it is has not mentioned here that this you need to use the convolution theorem, star only once you have used here in this course, star means only the convolution, right? And when we have two types of sequences, 1 by n factorial, 1 by n factorial, that means it is understood that here we are talking about the convolution theorem in Z transform. Okay, so now this is un, right? So un is 1 by n factorial and vn is 1 by n factorial. Both are same. Okay, so you know that convolution un star vn is equals to n is equals to m is equals to 0 to n um and v n minus m, right? So um means 1 by m factorial. I'll write summation here, and v n minus m, so n will be replaced by n minus m, right? Now see here, if I'll expand this, for m is equals to 0, you will get 1 factorial, 1 over 0 factorial, that is 1 over 0 factorial for m is equals to 0, n factorial, right? Plus for m is equals to 1, I'll get 1 by 1 factorial n minus 1 factorial, right? Then for m is equals to 2, 1 by 2 factorial, 1 over n minus 2 factorial. And it is going up to m is equals to n, right? So 1 by n factorial when m value is n. When m value is n, you will get 1 by 0 factorial, right? So when I just simplify it, 0 factorial means 1, so 1 by n factorial, 1 by 1 factorial this, and this again is 1, so 1 by n factorial. Now next step is, once you did up to here, we'll take 1 by n factorial common from this. Now common from this means, or you can say that simply will multiply and divide, means we divide and multiply by n factorial, right? So you will get 1 here, and then you just keep this as outside because we are dividing and multiplying by n factorial. So 1 by n factorial and inside n factorial, right? Now you can see here, if I simplify, this is 1 by n factorial, right? Inside it is 1. Now this n factorial, how can I write? N into n minus 1 factorial. Again, if you use this, means just n and n minus 1 factorial, that means n factorial only, right? So I'm just expanding this n factorial according to this, so that it will be cancelled out, right? Now here it is n minus 2, so I'll write n minus 1 and n minus 2 factorial. and in the denominator 2 factorial n minus 2 factorial, right? It is up to 1 only. See here, n minus 1 cancelled out, right? N minus 2 factorial, n minus 2 factorial cancelled out. So what you will get? You will get in the last 1 by n factorial is outside only. Okay, so I'm not writing that. And n minus 1 by 2 factorial. Next time you will get n minus 1, n minus 2. Third, 3 factorial. It will be n minus 1, and means see here. It is 1, right? Next term is, like, you can consider it as n minus, means here starting with n, right? Then here n minus 1 in second term, n minus 1, n minus 2, third factorial over 3 factorial. So what you will get? n minus 1, n minus 2, n minus n, right? And in that n minus n will be cancelled out, and you will finally simply get 1. So in the last you will have always 1 only, right? So 1, this. Now if you see this is nothing but the binomial expansion of x. If I'll just simply take x square, x cube, and so on, right? X power n. Okay, but in place of x, if I just take x is equals to 1, you will get here, right? But here this is the binomial expansion of 1 plus x power n. If there would have been x here, right? If x is not here, means if I take this like it was, don't take x here because it was not there. That means x value is 1. X value is 1. So you will get 1 plus 1 power n. That means 2 power n using binomial expansion over n factorial. So this you have proved. This is your proof. It is important so this was another example of convolution theorem. Next we have difference equation, and this is your module 7. So like differential equation, here we'll start with the difference equation, like a function y of x, also denoted as yx. So sometimes y of x we can denote it by yx. Now if this function is defined on the consecutive values of the independent variable x, here y is a function of x, right? That means x is independent variable, y is depending on x, so dependent variable. Now a plus h, a plus 2h be the consecutive values of the independent variable x, right? Consecutive value, which difference between two consecutive values should be same in all the further values of x, right? Means just you just take out two values of x, and then their difference always same. Like in this just we have h units of difference, then a plus 2h, between these two again the difference is h units, right? So at on the same intervals, you can say that with the same so with the same intervals it is defined on, right? So a plus h, a plus 2h, and so on with the consecutive values of in the independent variable x. Then the difference between the consecutive values is called the interval of differencing. Now two consecutive values difference is h, right? Here also difference is h, So this h is called as the interval of differencing, or difference interval. right? Now the value of the dependent variable is called the argument. Now see, these are the values of x. That means if we are finding the value of x at a, like x is equals to a, so this is nothing, we just called it as argument at a plus h, a plus 2h, right? So when we are writing y value at x, that means, and x values are a plus h, a plus 2h, that means ya plus h, ya plus 2h. That means y value at x is equals to a. Y value means y is the function of a, means was the function of x, and x value is a. Y value at a plus h. So these are the arguments. Okay. So once we, and now you can see that these are the discrete values of x, right? If y is a function of x and x is defined on some interval like 0, 1, that means we are talking about the continuous function. Now here x value is even discrete, a plus h, a plus 2h, with the differencing interval is h. That means the y function is given, means is defined on the discrete values of x, not for the continuous, and y is not a continuous function. Okay. So here next is the forward difference operator. So forward difference operator definition, given a function yx, the forward difference operator denoted by this is defined as this. Like forward difference operator, this is notation of the operator yx. What we do here, value of this yx, and because it is the difference operator, right, means we are finding the difference of y at some different arguments, these arguments, right? So difference of y at some arguments, and now these arguments should be two consecutive arguments. Now which one needs to be taken first, that will be defined by forward difference. Forward difference means, suppose you are finding the value of y at x, means this difference operator, here it is x, so we'll take yx, that means its next value should be x plus h, right? Then y x plus 2h, like that, this, because if h is the difference interval, so this will be the sequence yx plus h, yx plus 2h, yx plus 3h. So when we are using the forward difference operator, that means it is the difference, will take this first, means value of del yx will take this one and we'll just subtract this one. Forward difference means what is the forward difference from here to here with these arguments, forward difference, right? So y x plus h means y value at x plus h minus yx. So this is the forward difference, and this operator is called as the forward difference operator, or you can even write it as y x is y at x plus h minus yx. So here we are using these symbols only instead of this. Similarly, we can define the backward difference operator. Now the backward difference operator, given a function yx, the shifting operator denoted by this is defined as this. So like for the similarity, we'll find backward operator for yx only. Now this is the sequence yx, yx plus h, yx plus 2h. But for backward difference, we need this y at x minus h. Just one value of y, means argument of y, means this left argument of this. Okay, now backward. So backward means y value x minus this. If you are finding the difference between yx minus its one term, means preceding one term, to this term, preceding one. Okay, so that is the backward difference operator. This is the backward difference, and the operator used here is called as the backward difference operator. So yx minus yx minus h. Here it should be yx minus h. So it is the backward difference operator of yx. This. Or you can say yx minus h. This. Now the translator or shift or shifting operator. Shifting operator. Given a function yx, the shifting operator denoted by e is defined as this. Like if the difference interval is h, means between two consecutive values of x, there is a difference of h units. Okay, so this shifting operator, when it operates on yx, it will shift the argument to h units, yx plus h, e of yx plus h, where h is the difference interval. Now, after discussing this much, we have difference equation. So, a difference equation is an equation which involves an independent variable. Independent variable means x. And now x values are h. Okay. X values means values are x plus h, x plus 2h, x plus like this. Okay. So a difference equation is an equation which involves an independent variable, dependent variable y, and the successive differences of the dependent variable. Successive differences of the dependent variable. For example, this yh plus 3. H plus 3 means this. X value is given as h plus 3 here. Okay. Yh, then 3h square. Basically, here h is considered as the independent variable. Why? Because see, if y is a function of x, then x is the independent variable here. But anyhow, we have the values of xr, which basically depends on these differencing interval. That means x is independent variable which is having certain values. So that values contains h, right? So we are directly including h here as independent variable. Is a difference equation. Now, order of a difference equation. The order of a difference equation is the difference between the largest and the smallest arguments occurring in the difference equation. Now, smallest argument, this argument means value of y at x. So here value of y at h, it is argument is given at h, argument is given at h plus 3. So this is given as h, this is given at h plus 3. So what is the difference? H plus 3 minus h. That means 3. So the order of this difference equation is 3. Okay. Now, like suppose you have this type of equation, yn plus 3, n plus 2. Generally, you will get this only. Is equals to some n, right? So smallest is yn, largest is yn plus 2. So difference is n plus 2 minus n, that means 2. So this is second order difference equation. Okay. Now degree of difference equation. The degree of difference equation is the highest power of y present in it. That's it. Highest power of y present in this. For example, suppose this is difference equation is given. Now highest power of y is 4 here. This we are not talking about the largest argument than its power. Okay, like in the differential equation we were searching for the highest order than its power. Here simply search for the highest power of y, that is h. It is does not mean by, you cannot conclude it by the argument which one is the largest and then its power. So its value is 4. Now linear difference equation, a difference equation, this function of h, y h, h plus 1, this is equation, right? Any combination, any function which includes h, h, h plus 1, yh, yh plus 1, yh plus n. This is, see, the largest order is h plus n and smallest is yh. So minus h. That means they are talking about the nth order difference equation. Okay. So nth order difference equation, here it is called linear if degree of all the y present in it are to be first degree only. That's it. If they are present in first degree, means every term in this and products of y do not occur. First thing is each power will be 1 and there should not be a product of y. Like in this, if suppose you'll take given the power here h plus 1, like something. So power is 1 here, it is 1, it is 1. But there is a product also. So there should not be a product to be a linear difference equation. Like this. As simple as that, yh plus 3, 3y and this. Here the order is h plus 3 minus h, that means 3 order and degree is 1. So this is 3 order 1 degree difference equation. Now we have solution of difference equation and 2 more classes also left and only one topic that we can finish in one class itself. So we'll discuss more topics in next class, the remaining topics. Any doubts? Nobody is responding. Any doubts?
No, ma'am.
Okay, so just see this, because this is module 7, right? And in FAT exam, 7 questions. 7 questions need to attempt 6 questions, right? That means 1 question per 1 module. Okay. Now, because this is the small module, difference equation. So obviously 1 question you will get from this module. And this question is very simple to solve, difference equation. So don't lose that. If you, because on choices for 1 question only, so don't skip this. You can skip the question of power series. That will be tough to solve because it takes lots of time to solve the power series method, even that Frobenius method. Okay, so don't skip this topic. It is very important and very simple also. Okay, then I'll take your attendance, then you may leave. attendance, everybody.